Find the volume of the solid E that lies within both the cylinder and the sphere. So it's like that solid E is inside this and also inside this sphere. So basically it's top and bottom, up and down, covered by this, because this is cylinder going forever, and we have a sphere something like this, so pretty much something like this solid. And we have above, for G bound, the height kind of G bounds are given from here, because we can write this as x squared plus y squared plus g squared equals 4. Move this over. So basically it mentions cylinder, that means we are using cylindrical coordinates, okay, r, theta and g. So this is r squared, by the way, so g squared equals, move this over, 4 minus r squared. Now g equals, take square root, 4 minus r squared plus minus. So the lower bound would be negative this, and upper bound is plus for g, for height. And we have inside this x squared plus y squared plus 1. So if we look at this solid in the xy plane, the projection of the solid in the xy plane is just a circle. So in 3D, x squared plus y squared equals 1 is a cylinder, but its projection on xy plane is a circle, okay, centered at origin and having radius 1. And as we know, the volume will be just triple integral, the function is 1 dv, and we can always reduce this triple integral into double integral d, where d is the projection of the solid in xy plane, and dA, that's the area, change in area, and inside is g 1 dg. And for this question we just found the limits for bounds for g in polar, so that is negative 4 minus r squared to positive 4 minus r squared. And the next we want to write this, okay, here g equals negative 4 minus r squared to 4 minus r squared, function is just 1 dg. Now we want to write this in terms of polar, that means r dr d theta, okay, r dr d theta, and this is the region D, by the way, the projection of E in xy plane, and this one is goes around, so theta is just 360, 0 to 2 pi, and r, okay, r is 0, all the way outside is 1, so r from 0 to 1. Okay, let's evaluate this. First we want to integrate with respect to g. We don't have just 1, so let's do this, then go outside. Okay, so here theta from 0 to 2 pi, and this one with respect to g, so this r we can pull outside of this integral, r from 0 to 1, and we can write r here. Antiderivative of 1 is just g with respect to g, and we have bounds root 4 minus r squared over negative 4 minus r squared, and dr d theta. I pulled r all the way out here. We cannot pull all the way because this is for r. Theta from 0 to 2 pi, r from 0 to 1, r upper limit minus lower limit, this one minus negative, so basically same thing, this one plus this, so 2 copies of 4 minus r squared, and we have dr d theta. Now we need to integrate this. Here is theta from 0 to 2 pi. This 2, in fact, we can pull all the way outside. That leaves r from 0 to 1 of r times 4 minus r squared dr, so we are interested in this d theta. Now how to find the antiderivative of this, because we got a product, but if we look at inside 4 minus r squared, its derivative is negative 2r. we don't have that, but we can multiply by negative 2 and divide by negative 2, anywhere divide by negative 2. Okay, so this will be like root u, and negative 2r dr is du. So basically we are doing u sub, so 4 minus r squared du is negative 2r dr, we have that. So this becomes root u du, and antiderivative of root u is u raised to 1/2. So 1/2 plus 1 3/2, 2/3, and u is 4 minus r squared. So I'm going to write this down here now in the next step. So this cancels, it's negative theta from 0 to 2 pi. So antiderivative of this, using this, we got 2/3. U means 4 minus r squared raised to 3/2, and we need to evaluate this from 0 to 1, and we have d theta. Okay, I went too far, let me go up. Here is negative 1 theta from 0 to 2 pi, 2/3. We can pull all the way outside if we like. So upper limit 1, so 4 minus 1 4, 4 raised to 3/2. So we'll take care of this later. That's upper limit minus 4 minus 1 squared, 4 minus 1 3, not 4. So 3 raised to 3/2, minus lower limit 4 minus 0, 4 raised to 3/2. 4 is 2 squared, so this is 8 by the way, and this number is negative, and d theta. So there is no theta left, so we can pull all the way outside. So this is, by the way, negative, this is 2/3 outside. If I switch, if I write 4 raised to 3/2 minus 3 raised to 3/2, I get negative 1, and that negative takes care of this negative. And there is 1, antiderivative of 1 is theta, and upper limit lower limit just 2 pi, and this is whatever this junk is the answer. 2 times 2, 4 pi over 3, and here is, this is 2, okay, this is 2 squared, so 8 minus 3 raised to 3/2. Final